it's, powerful, yeah. Yeah, it's pretty well gone, mate. Pressing the button to take it away.
Hi, welcome to another episode of The Art of Engineering. Sorry it's been such a long time since I've put something up. Been very, very busy playing radio. The thing is, I do love making these videos, but I also love playing with the technology. I feel like rather than being beholden to a schedule of 1 or 2 videos a week, that's like putting the cart in front of the horse. I really want to investigate technically what's going on. I'm not a technical genius by any means, but I've found that the more you play and the more you experiment, the more you learn. So with this project, the Elektor SDR hands-on project, this originally launched in like 2007, so it's quite old school technology, and it's had a reboot quite recently, probably still 3 years ago maybe. The thing that got me interested in this was the founder, Burkhard Kanker, DK7JD, who was a physics teacher. So we've got that in common. Not that I'm a physics teacher, I was originally an art teacher, but interested in technology and microcontrollers and just the amount of things he did with this shield. Now, every other video I've found on this particular project in this shield has been solder in the headers, plug it in the Arduino, get it operating on the software that they initially tell you to try out, which is, it's an interesting piece of software. It's obviously had a lot of effort put into it. That software is by a gentleman by the name of, let's get this right, Peter Carnegie, G8JCF. And what's great about that software, of course, is you plug in the shield, connect it to the software, and then the software actually loads the script onto the Arduino. Now, the problem I had with that was that you can probably find the scripts or the sketch for the Arduino somewhere, but I, for the life of me, couldn't find it, which meant that I couldn't really modify what was on the Arduino, because once it's compiled and sent to the Arduino, it's sent as, it becomes a machine language, and you can't just download it back onto the IDE and play with it. So what I did was I did a lot of searching around, and I found another resource, well, several resources. But most of the people that play with this device plug it into that software, get it receiving, go, there you go, I'm up to page 20 in the book, and this is great. Well, the spirit of this device is to do a lot more with it. Now, Burkhard has turned it into a standalone transceiver. Now, I am thinking I would like to get this thing transmitting as well, but I did want to get an LCD screen working on it and everything else. Enough of me babbling on. I'll show you where we got to. It's that time in the video where I'm going to ask you to reach down and hit subscribe, and maybe hit the like button or the dislike button. Thank you for watching. Back to the video.
Hello, we are back on the bench. What I'm going to be doing is I'm going to be fitting the headers in this Elektor Shield, which is an SDR receiver. Pretty old school in so much as it's not interfacing through USB. We're doing the audio cable thing. But what I liked about the look of this kit was that it's opening me up to exploration of SDR as a possibility for building for QRP. Now, the course that I've just failed at university, failed by virtue of the fact that I just stopped doing it, which is terrible. It's lazy on my part, but I got too taken away with playing with radio stuff, and I thought, why am I doing this to myself when I could just be playing radios? So I've got this wonderful kit full of a breadboard, and it's got 7-segment displays and remote controls, and it comes with the Arduino. And the Arduino Uno, which is in that packet there, is what the Shield will sit on top of. For all those that don't know what Arduino is, I would say jump on the Arduino site and have a good look at it, but it's a microcontroller that is open source, and it basically allows you to use lots and lots of software libraries. I'm by no means a software expert. In fact, I'm completely hopeless at it. You are able to borrow, not even borrow, they're giving you the code. It's open source, as is the actual technology as well, the hardware. And the Arduino provides you the opportunity to build lots and lots of amateur and ham radio type projects. A lot of people use it as a starting point for a DDS VFO and all that sort of stuff. So we're going to be taking this Uno and this Shield. We'll get it operating as a receiver first off, and then I'm going to play around with the idea of turning it maybe into a whisper transmitter or a QRP transceiver, or lots of different things. And I also have in this stuff that I got from uni, which was a lot of fun, is the field programmable gate array. Now, for those of you that don't know what one of these is, if you were like me, of the vintage that did digital electronics a long time ago, you may have had digital trainers where you built circuits up on those. This thing actually emulates digital gate arrays and digital type circuits, and you're able to build the circuit in the virtual realm on a PC and then flash it onto this device, and this device behaves like the circuit that you've created, the digital gate array that you've created. It's incredible stuff. Yes, it is complex. I will not lie to you. There's a steep learning curve on the software that's required and whatnot. That would be very fertile ground for exploration in the ham field of home brewing. But I'm putting that aside for the time being, because we're going to be playing Arduino and we're going to be building this SDR receiver. I'm not going to show you soldering headers and whatnot. We all know how to do that. And that is that. So let's get this sitting on top of our Uno. And that sits on top like that. Now I'm not going to push it down because I still need to mount my antenna socket and whatnot. Yeah, neat little setup.
Now the bit where it always gets really interesting, because I am lost on computers, be it on the Linux system that I run over here or on our good old PC. They've said here that you've got to go, I keep winning stuff from Bunnings, you know, weird pop-ups. We are in the Golf 8 Juliet Charlie Foxtrot software-defined radio section, and this is the software that when you actually load the software and plug it into this Arduino with the Elektor Shield on it, what it does is it loads a lot of the libraries and stuff that you would normally have to load manually using the Arduino IDE. Now, if you've never used Arduino, you don't know what I'm talking about. This is probably one of the good things about this situation, is that it just cuts out all the difficulties. But at some point in time, you're going to have to understand how to use the IDE, and that will increase your enjoyment of Arduino anyway. But for the sake of plugging it in, getting an antenna into it, and seeing it operate, that is a clever thing. Anyway, we'll load the software. We all know how to install software, I'm assuming. And, you know, the difficulty, of course, is that on anyone's computer, depending on their operating system and what's going on with their computer, there's always going to be either a really simple install or a nightmare. Anyway, I'll get the software on this computer and we'll plug everything in and we'll see if it works. This is the G8 JCF SDR software, and this is a software that's recommended for running the Shield when you first start it up. And last night I spent the best part of like 6 hours trying to get this damn thing to work on the broadcast band. And, you know, knowing what I know, which is very little, as you guys have probably realized, I should have realized that I was going to get nowhere with this, because I was trying to do what I thought would be the easiest thing, which is tune a broadcast station. But this has no pre-selection, no front-end selectivity as such. And because of that in the design, you really need to, if you want to start using it for a particular frequency, start putting in some filtering, either band pass or low pass or something to stop the front end from being completely obliterated by strong signals. So here I was thinking that there was something very, very wrong with the actual shield and that it wasn't working. I didn't even bother trying it on higher frequencies or ham frequencies. So I thought if I can't get it to work on the broadcast bands, it's never going to work anywhere else. But of course, today I've been operating into my half-wave inverted V NFED for 80 meters. And today I thought, well, I'll just try and see if I can find the trusty old Moore speaker from the WAA. And there it is. The biggest problem was the actual antenna was providing too much signal and the RF amp was being completely swamped. So it is working. I would say that the actual instructions, there's a lot of information. There's a lot of things that need to be happening if you want to take it any further with perhaps building a whisper transmitter or a transceiver or whatever. I like to be challenged, but I did find some of the information in the book a little bit over at least above my limited abilities. And I would say that I have done a little bit of work with Arduino. I still found it quite difficult, but the information's there. You can also find information online. I am going to now try and get this to work with SDR Sharp. SDR Sharp, I'm having the problem that the IQ signal option doesn't seem to be in the menu anymore. So I'm going to have to work out that problem. And then I'm going to try and work out how to calibrate this thing. So it's very, very, I found it very, very challenging. But the aim with this particular unit for me will be to get it on the air as a 20 meter CW transceiver. And hopefully it'll be standalone as well as married to a PC if the one is available. So that is the aim. Let's see if we manage to do that. And here are some 40 meter signals, lower sideband. This is IZ3NYG calling CQ. So we've managed to get this shield going with the LCD display. The original booklet, the SDR handbook, actually uses a shield. The shield, as far as I can tell, is no longer in stock. So I've had to like search high and low. And in a moment, I'll show you the resource that I found that I've used to give credit where credit is due, and found a blog where a gentleman had bought the original version of this that didn't have the transmit function on it. What this allows you to do is it allows you to step through various tuning ranges. You can set a start and a finish frequency in the sketch as well, and it tunes really, really nicely. So I'm really happy that that's all working, and the whole thing gets demodulated in HD SDR. HD SDR isn't showing change in frequency and whatnot, so it's not responding to the actual shield. But the plan eventually is to make this a standalone rig, or if I do use HD SDR to do the demodulation and modulation, I'm still going to be relying on this. Now, waterfall probably would be nice. My abilities to code, especially in the IDE for Arduino, is very limited. So that's something that I need to definitely spend more time on. I'm just happy that I've managed to get this going with the screen. The plan is to eventually get a DDS VFO going as well. So this bodes well for that sort of situation. The SDR handbook used this screen without the I2C bus, which means you need to use more outputs and inputs and whatnot. So I think this is a more sophisticated solution to the issue, and it's receiving quite well.
Name Laurie. There's a bit of DX.
Now, if you were to watch the videos that are online, you would probably think to yourself, this is going to be a really easy project. And I think getting it just to operate as a receiver using the supplied software, it's not too difficult. But did I have problems? Yes, I did. Now, one of the things that's happening with laptops in general is that they're doing less and less outlets on them. Once upon a time, they would advertise the fact that they had HDMI coming out of it and D connectors and RCAs and all this sort of stuff. And slowly things have become more and more wireless. Connectors have become smaller and there's less of them. And one of the things that's happened with most modern laptops is you have the 3.5mm jack that is both a microphone and a headphone. And so the first problem that I came up against, and you may very well come up against this if you decide to use a modern laptop and buy this kit, is that you will buy your standard line connector, the 3.5 with the jacks at either end, and think plug, select the right devices, off you go. Well, when I first plugged this in, if I was plugging this into a laptop with a microphone input, not a problem. It would have worked fine once I selected the correct device and whatnot inside the control panel on the PC. But it was refusing to see this as a microphone. So the next thing that I needed to do was I ended up going to JCar. I'm sure you could buy these online a lot cheaper, but it has a split so that the red one is the microphone and the green one is the headphone. There's probably easier ways of doing that. Maybe make up a cable. I find that, getting my head around this tip, ring, sleeve business and everything else, every rig I've ever built kind of just like metered it out and, put alligator clips on it and tried to work it all out. So very lazy, my approach, very organic. So what is the verdict on the Elektor hands-on SDR Shield and book? Anytime I see a project with a huge amount of investigation and passion invested in it, I have to say great things about it. Now, I know a lot of people are going to say you could buy an SDR dongle probably cheaper, that probably works better. By doing that, you're not given the opportunity to investigate, to play. So I have had a lot of fun with this Shield. My intentions moving forward are to make it into a 1.8 megahertz, 160 meter transceiver and try and get a contact on CW using that transceiver. So already I've had hours of fun with it. The book's got a heap of information in it. Like I said, it's a beginner's book, or it's a beginner's Shield up to the point where you get it to be a receiver. After that point, there's going to be effort on your part, or you'll have to have the knowledge already in your noggin, how to use an IDE, how to play with Arduino. But just the opportunity to get involved with Arduino and have some fun with it. So even if you're not maybe up to speed, you can always buy the Shield, get it to be a receiver, and play with it around those ideas. There's certainly in this booklet here a whole heap of investigations regarding antennas that you can build in your house. So if you're a new ham and you haven't listened on the ham bands, this might be an opportunity to play with antennas and to do some listening. And then down the track, when you get your license, you can maybe turn it into a transceiver and make a contact on it. Now, for those that have been following this channel, you'll know that at the very start, I had no equipment. I made by hand a Morse code key from parts that I bought at a hardware store. I built the station. It was a 2-transistor transmitter and a direct conversion receiver in an old chocolate box. And I've gone from there to homebrew kits, OzQRP kits for 40 and 80 meters. And then I got myself an old boat anchor. So it's a disease, essentially, this thing of ham radio. You're going to be acquiring equipment. Now, I could have bought myself a shack in the box, and there's nothing wrong with doing that. If you're a contester and you want a rig that performs really, really well, that's probably the way to go. But I really like that opportunity to build for each band. And then down the track, I'm sure at some point in time, I'm going to buy myself a high performance rig. But at the moment, the plans are to keep building band by band and just enjoy the investigations that come with that whole process. And like I was saying, the book here is a great read, and it's just exciting to see someone else who is excited about home brewing. Thanks for sticking around to the end of the video, and I will see you in the next episode of The Art of Engineering 73.